Hello, I'm Jacob from Intrepid Protoworks, and today we're going to go over the one sample t-test. To get started, we're going to go ahead and get a function for the mean, the sample standard deviation, and the sample standard error of the mean. We've covered these concepts in previous tutorials, so go ahead and reference earlier tutorials if you're curious about more detail on those functions. The one sample t-test will be the first of 3 t-tests we go over, the other 2 being the independent 2-sample t-test and the last being the dependent 2-sample t-test. So now we're going to go ahead and make a function to get our critical t value. This will let us evaluate whether or not our test is significant. So it's going to take 3 arguments. It'll take our alpha level, our sample, and a test type. Once we get that, we will go ahead and get our sample size, which will give us our degrees of freedom. So in case we run into large samples, we're going to just say if the degrees of freedom is greater than 120, we'll just set our sample degrees of freedom to 120. Alternatively, we could reference the z table at this point. We'll save that for another time though. We'll go ahead and set our critical t to 0, and then we'll start going through our different test types. So if the test type is two-tailed, we'll open up our t-table and we will loop through it, and if our degrees of freedom match what we find in the table, and then we'll progress through until we find if the alpha matches a given probability value. Now, because we're looking at a two-tailed test, we will want to do 1 minus our alpha divided by 2. And that will give us something like, for example, in 0.05, it will give us 0.975. And then we will go ahead and set the t value that corresponds to that, and then return that t value, and that will give us our critical t. For a positive one-tailed test, it's almost exactly the same. We go through the table and everything, except we don't divide our alpha by 2. So in other words, our p value that we're getting the t for is going to be 0.95, an example of alpha equaling 0.05. And it's even more simple for a one-tailed negative test, because then it is only looking at the alpha on its own, so 0.05. After that, we just return the critical t value. For our next function, we're going to go ahead and get p from t. This is a little bit redundant, but most of the time when you're wanting to report statistics, you're going to want to make sure you have a p value that you can report. So we'll do something a little bit different. We'll just define p is equaling none, and then the same thing. Again, we could sub this out for referencing our z table instead if the degrees of freedom are greater than 120. And then we'll do if our t is greater than 6, which is outside the range of our t table, we'll just say p equals 1. And if t is less than -6, we'll say p is 0. At these points, these are not technically true, but very, very close. Most statistics packages will actually return something like this because you're looking at 4 5 zeros and a 1, or 4 5 nines. Then the interesting part comes in where if the t value is somewhere within that range of -6 to 6. We'll again just go ahead and grab our t-table file, and we will loop through it to find where the degrees of freedom and the t match up, and then we'll get the p value listed there, and then we will return that p value. With the critical t and p functions in place, we can go ahead and make a one sample t-test. So this function will go ahead and take our sample, our population mean, our alpha, and our test type. Now, a one sample t-test is very similar to a z-test. The only real difference is the distribution that we take it from. So we take it from one of the t distributions, and that is dependent on the degrees of freedom. The result of this is that the one sample t-test is more conservative. It's harder for it to determine whether or not the difference is statistically significant. So we've got our mean, our sample size, our standard error of the mean, our degrees of freedom, we defined a variable called significant and started out as false. Now we've calculated our t by taking our sample mean and subtracting our population mean and dividing it by the standard error of the mean. We'll go ahead and do get p from t. We'll pass through our t and our degrees of freedom. And then we'll go ahead and evaluate this based off of the type of test. So again, we have a two-tailed test, a one-tailed positive test, or a one-tailed negative test. And we'll go ahead and do our critical t and do this for each version. So with a two-tailed test, we need to see if our t is less than the negative critical t or greater than the positive critical t. If this is true, then we will set significant to true. Next, we'll go ahead and make an else-if statement designated as elif in Python that will look at one-tailed positive and one-tailed negative tests. For the one-tailed positive test, it will see if the t value is greater than the critical t. For a one-tailed negative test, it will check to see if the t is less than the negative critical t. And while we're at it, we might as well move the crit t variable up out of this. We don't necessarily need to calculate this 3 times. The critical t itself will be the same value because we've already calculated this in the function that gets the critical t. We don't need to have a repetition here. Once we are done, we will go ahead and return a whole bunch of values. We will go ahead and return if it is significant, which will be true or false. We'll return the t value, the critical t value, and the p value. These are all things that we like to look at in statistics. And that does it for the actual code for our t-test, our one sample t-test. Let's go ahead and tighten up our code a little bit and move on to an example. So this first part of the example, we're going to go ahead and just get general population income, and then we'll go ahead and get the Black female income data. And then we will go ahead and reference our data that we've been using for this tutorial series, which we got from the IPUMS website. This is taken from the American Community Survey 2017 and includes about 3 million data points. So we'll go ahead and filter out parts of our data that we don't necessarily need to look at. We'll filter out the header. It's not particularly relevant right now. We'll filter out if the income is ambiguous or negative. We will filter out if the person reported not applicable, which is coded as 7 nines. We will filter out if the person is under 18. And with all those filtering mechanisms in place, we will then add the income value to the general population data, and then we will evaluate if they are African American. We will then evaluate if they are female, and if they're African American and female, we'll then add them to the Black female income data. So as we're looking at a t-test example, not a z-test example, we're going to go and import random and then get a sample of data for Black females. So we'll call this Black female income sample, and we'll define it as random.sample. We'll take our Black female income data, and we'll go ahead and just do 15 for our sample size. Next, we'll go ahead and grab our population mean, which we need for a t-test, and then our sample mean, which we'll want just for the sake of reporting our findings. Lastly, we'll go ahead and do our alpha. We'll go ahead and set it to 0.05, and then we will do our test type as a two-tailed test. Now we can go ahead and do our one sample t-test. We'll go ahead and define 4 variables here. We'll do our significance bool, we'll call it sig bool, our sample t, our critical t, and our p, and we'll set this equal to one sample t-test. And in it, we will pass through our Black female income sample, our population mean, our alpha, and our test type. Because this is long, we're going to go ahead and wrap this down, fixing a typo real quick. That way we don't have to extend the typing off of the screen. We will go ahead and double check that we got everything right. Sample, pop, mean, alpha, and test type. So it looks like everything's correct. Now we'll evaluate the results of our test. So we'll say if sig bool, if that is true, we will print out that the one sample t-test returned as true. We'll report the p-value, we will report the t, we'll report the critical t, and then we'll report the means for each. We'll also do the exact same thing if it is not true, except we'll report that it is not significant at our alpha. We'll go ahead and hit save and run. Make sure we run it in a new independent console. We have an error. We need to replace that dot with a comma. We need to replace another dot with a comma. We're looking for that now. Just go ahead and click this where this error will show us where it happened. And hit save and run again. Looks like we did this a number of times, probably from the copying and pasting earlier. And now we have it running. It looks like we have, we put an F instead of T. And we'll do this one more time. And we put CDV instead of CSV. We have a lot of typos tonight. Sorry about that. T-test is significant at alpha equals 0.05, where P equals 0.01, and the T is 2.56. We'll run this again with 100. Our T is -11. Our critical T is 1.99. Run this again. You can see that turned out not significant this time. So we can see that this is a good example of, we know that there is a statistical difference from our z-test video where we looked at the entire population. We know that there's a really big difference, but we see that sometimes if we have a small sample size, our statistical tool will report a spurious result. This is part of what we accept for the possibility of returning a result that is incorrect. This is also why it's essential that we always report all the information. That way somebody can look at it and be like, you know, 10 is really small. Are you sure you had enough statistical power to correctly evaluate this question? Also, statistical power is a concept we'll look at a later point. While I've been talking, I've been just going through and running this so I can see it. Let's go ahead and play around with a few other types of tests. So we'll do one-tailed negative. This makes a lot of sense to go through. We have our critical T. See, this is why reporting the critical T is important. We see that we've made an error. Looks like we added a space in, so it wasn't correctly evaluating the right type of test. So we see that is not significant. Our P equals 0.38. Go ahead and run this again. Test is significant, and we can see that the critical T is different when we run different types of tests. There's a little bit of additional power when you state that when your theory is that there's not only a difference, but there is a difference in a specific direction. And this is reflected in a lower critical T value. We'll do one-tailed positive is not significant. Critical T is 1.7 and our T is -0.48. Run this again. You see that it still is not significant because, again, we're making a theory-based statement that we would say that female Black income is greater than the general population. And we can see that that test is returning as not significant because that's not what the data is reporting. In the future, we will also go over the statistical concept of power, but next time we'll be going over the two-sample independent means t-test. After that, we'll go over the dependent means t-test. And then after that, we'll probably at that point look at power, look at the F distribution, and continue along with the series. Thank you for watching. If you have any questions or comments, make sure to leave them down below. And don't forget to like, subscribe, and turn on the notification so you can see when our videos come out next.